In this video, we're going to talk about the properties of logarithms. If you have logarithms in an expression or an equation, we're going to see what can we do to break them apart or put them together. Basically, what are your limitations? What are the things you can do? And one of the nice things with logarithms is there's not a whole lot of things you can do. This is our list of things. We can switch it from log form to exponential form. To do this, look at this. We got to have just a single log. Can't have anything outside the log. Can't multiply it by anything. Can't be adding anything to it in order to switch it from log form to exponential form. So if we have things going on, we can take a log of a product and break it up into a log, adding the logs of the two factors. So if we have, or the other way around, if we have adding two logs together, we can combine them to get to a single log. If we're subtracting two logs, we can combine them into a quotient. Or if we're taking the log of a quotient, we break that up into subtraction. Makes sense if when we multiply or take the log of a product, we're adding logs. The opposite of multiplying is dividing. The opposite of adding is subtracting. Finally, if we're taking the log of a number to a power, we can take that power and bring it down in front of the log as a multiplier. So the log of x to the n equals n times the log of x. And then our simple ones, the log of 1 is always 0, and the log of the base is always 1. Thing to kind of keep in mind when we are doing this, and to make a little bit more sense out of these properties, is remember the fact that the log gives you the exponent. So our properties of exponents, when we multiply two things together, we add the exponents. When we divide two things, we subtract the exponents. When we take a number to a power, we multiply the exponent times that power. It's using those same ideas of the properties of exponents because the logarithm is the exponent. So we're just going to work through a few examples of condensing and a few examples of expanding. I'm going to start with some examples of expanding logs. When we expand the log, we take a log of a bunch of stuff and turn that into many logs. Each log is going to be of a single number or a single variable. Sometimes this will make it easier to work with. When we do this, we're going to be doing order of operations backwards. On this first one, we got 7 times x to the third. And also, to see kind of why we got to go backwards, this third power is only on the x. It's not doing anything with the 7. So I can't do anything with that third power till I get rid of the 7. I undo that. So I'm first going to deal with the multiplication. Then I deal with the power. So I'm going to use my multiplication property here and change this into a sum of logs, log base 4 of 7, plus log base 4 of x cubed. Then I'm going to use my power property, which allows me to take the power, bring it down as a multiple, and I get the log base 4 of 7 plus 3 log base 4 of x. As I go to this next example, again, I'm going to first take care of this division. So I'm going to make this the log base 7 of 4 times the square root of x, not plus, minus the log base 7 of 9. When we divide, we subtract, just like with exponents. I'm going to break up this multiplication here and make this the log of 4 plus the log of the square root of x minus the log of 9. And now we have this radical problem because none of our properties deal with radicals. And This is everything we can do. If it's not here, we can't do it. With the exception of change of base, evaluating these logs. But I can rewrite x, the square root of x, as x to the 1/2 power, and now it's an exponent. Now it's a power. I got a property for that. So I got the log base 7 of 4 plus 1/2 of the log base 7 of x minus the log base 7 of 9. Oh, I forgot the base there. This is a number. This is a number. I can turn those into numbers, subtract them, and I'm down to one logarithm, and it's a log of x. So I can use that easily to eventually switch to exponential form and solve that. Let's take a look at this last example. I'm going to give myself a little bit more room to work here. The log base 5, 15x cubed over xy to the 4th. So, again, I'm going to start with this division. Oh. So I'm going to get the log base 5 of 15x cubed minus the log base 5 of xy to the 4th. But the log base 5 of 15x cubed, like on that first example, I can say that's the log base 5 of 15 plus 3 log base 5 of x, because I used the multiplication product rule and then the power rule. When I take the log base 5 of xy to the 4th, that's the log base 5 of x plus 4 log base 5 of y. But I'm subtracting these. So when I'm subtracting that whole log. So that's important to leave it in parentheses. I'm subtracting both of those. Or to distribute this and say I'm subtracting this log and I'm subtracting that log. Now when I look at that, here's a log of x and here's a log of x. I can combine those together. Log base 5 of 15, 3 log of x minus the log of x is going to be 2 log of x. And this minus the 4 makes that negative 4 or minus 4 log 5 of y. Now, I could have skipped a step and saved me a little work by noticing right here, I could use properties of exponents and simplify that down first. The log base 5 of 15x squared over y to the 4th and not have to mess with that. But I don't see that. When I break it apart, I can see some of those I can do. It reinforces those properties of exponents. So now let's go the other way. Let's condense logs. When we condense log, we're taking several different logarithms, putting them together to make it into one single log. Again, the important thing is we have to have the same base on all of my logs. On this one, we're going to actually use order of operations because we're doing the opposite of what we did before when we're going backwards. So when I have this first example, log of 5 plus 3 log of y, first I have to take care of the multiplication. Then I'm going to take care of the addition. Take care of the multiplication, I'm going to use my power rule. 3 times the log, that's going to go up into the exponent. So we're going to get the common log of 5 plus the common log of y to the 3rd. Now I can use the multiplication property and make that the log of 5 y to the 3rd. Now we're down to a single log. This is convenient if I want to go to exponential form. I need log of a number equals something. When I look at this definition right here, I can't have anything but a single log. So that's one reason we do this sometimes. Let's look at our next example. 2 log base 3 of x minus 3 log base 3 of 4. Again, first I'm going to take care of this multiplication, so I'm going to bring these as powers. I'm going to make this the log base 3 of x squared minus the log base 3 of 4 to the third. And now I can deal with this subtraction. So that's the log base 3 of x squared over 4 to the third, or the log base 3 of x squared over 64. Short and sweet. Now let's look at this last example. On this last example, we got to worry about the parentheses involved. So, again, order of operations, first I have to do what's inside the parentheses. So I'm going to make that the log base 5 of x minus 4 times the log base 5 of 2x. Now I can take advantage of the power rule and bring this up as a power. But I got to realize I'm taking 4 times the entire log, so I'm taking everything to the 4th power. So this is going to be the log base 5 of x minus the log base 5 of 2x to the 4th. Or it might be a little easier to do that, use the property of exponents to make that the log base 5 of 2 to the 4th is going to be, well, 16. Undo that. Undo. X to the 4th. Now I can finally take care of my subtraction and do my quotient rule. Log base 5 of x over 16x to the 4th. And say, hey, wait a minute, I can do a little bit here. I got x over x to the 4th. Let's simplify that. The log base 5 of 1 over 16x to the 3rd. And like on that example I did with expanding, I could have at this point say, hey, I got a log of x and a log of x, so I could distribute combine like terms before I do all this mess. Either way it works. But this is basically what we do. Anytime we want to do anything in an equation with either with logarithms involved, if I want to do any operations with logarithms, this is everything I can do. If it's not one of these things, there's nothing I can do. So we're really limited in our operations. Sometimes it's good to condense it down one log. Sometimes it's good to expand it into many.